Hello, my name is Paul Anthony Lassen. My instructor is Raul Vargas, and this is my video project for Fundamentals of Physics. In this video, I was tasked with demonstrating a scientific concept and describing how it relates to my game design degree program. When designing a game, the implementation of physical concepts is incredibly important. While the designer typically does not have a direct hand in implementation of velocity, acceleration, or gravity, it does have to be established in what ways those concepts apply to the world that the development team is crafting. The concept I'm choosing is gravity. How gravity in games is implemented, in what ways it is taken into account, and in what ways it is ignored or completely done away with for the sake of creating gameplay diversity. Gravity has been a part of gaming as early as 1962, when Space Wars gameplay pit two players against each other, battling in starships while within the gravity well of a star. Players could utilize the gravitational field to affect their maneuvering, speeding up through the use of slingshot maneuvers, breaking orbit once their velocity reached a certain point. Despite its gravity role in navigation, it did not affect the missiles that the players would fire, due to the lack of processor power in the 1960s. Moving forward, gravity has become a mainstay of most video games. Jumping is used as a main traversal option in most platform games, and as a result, gravity's role in said jumping is integral to the gameplay experience. Consistent gravitational presence is considered a given in video games, though being present and being important are two different things. Gaming has made staples out of gravity-defying feats such as double jumping, personal flight, wall jumping, air dashing, or even gliding without taking into account gravity's role in such activities. Moreover, gravitational acceleration is typically never taken into account in most games. While gravity may have a consistent presence in games, characters tend to fall at a steady rate, never accelerating at the rate of 9.81 meters a second. Even if we take into account that we can't really determine the distance in which someone falls, we can clearly see that characters fall at a specific speed and rarely accelerate. The exception that immediately comes to mind is the Super Smash Bros. Franchise. Players can choose to fast fall as a way to increase maneuverability. But the Smash franchise bucks gravitational law by allowing players to fall at varying rates based on the character's mass, something that isn't true if the game doesn't take into account air resistance, which it doesn't. Overall, gravity is very important when creating a video game, but the specifics such as acceleration or gravitational constants are often toyed with to expand gameplay possibilities. Understanding how gravity works is important if one wishes to give players a better, richer experience overall. Thank you for your time. My name is Paul Lassen, and this has been my physics video.